Okay.
You forgot an n with the 72.
Thank you. You're right. I did. Otherwise, the entire question makes no sense because they want to know. So they want us to isolate variables, and they've asked us: is there a value of n that makes these equal? Right. Okay, let's take a look at this. So what we're testing for is equivalence between two functions. F of x equal to g equal to x, and that's the question. Are they able to be equal? So we're going to set up this exact scenario. We're going to put an f of x on the side, but in this case, we're going to replace f of x with what it's equal to. So we have 13x squared minus 10. So this is kind of that f of x piece that we talked about is equal to. And then g of x on this side is negative 9x plus 72n squared, and that's the g of x. So we replace those two, think of them almost as like names of the function. We've replaced them with the names with what they're equal to. So now the goal here is we're looking for a value of n. So we got to isolate n here. There's a couple ways. My instinct personally is to get rid of roots really quickly. I would square root this, but I'm going to end up with this square root over here. It's going to be really messy to work with. I'll show it at the end as another way for potentially answering it. But thinking about what you guys have learned, I get the feeling they want you to do some expansion on this side. They want you to expand this so the root is gone. So what I'll do here is we'll leave the left side the same. Whoops, I don't want that color. 13x squared minus 10. And then we're going to expand. Do you have a calculator handy?
Yeah.
I know already that I'm not going to be able to mental math this binomial expansion. Okay. So this is what we're going to be looking for. I know my negative 9, that'll work out fine. So we're doing first terms. That's going to be 81. Two negatives is a positive, x squared. Negative 9 times 72, I don't know off the top of my head. I'm going to leave that one to you. But I do know.
Negative 648.
648.
Yeah.
Okay. And there's an x and there's an n. So I got two variables. I have an x and I have an n. Okay. And we have positive 72 times negative 9. That's going to be the exact same thing. So negative 648xn. And then we get 72 times 72. I don't know that one, but it's going to be n squared in the end there.
5,184.
Nice. So positive 5,184.
Yeah.
Okay, so we've got this very large amount here. What we would like to do is try to isolate for n, but through this expansion, I've actually created 3 n's. So this is going to be difficult. The factor version's going to be the better one to work with. I'm going to move some things to the other side and then see if we can work from there. We'll move this 81 over so it's with its like terms. So we'll have 13x squared minus 81x squared minus 10, okay, is equal to. And then I got a nice glare on that. There we go. On this side, I'll put them in order. We have 5,184 n squared. And this one is going to be negative. When you add those together, what's that give you? Almost 1,300 minus 4, so 1,296. You want to just double check that for me? X n.
Yeah.
Yeah, okay, good. Okay, I'll simplify this side here. This is going to give us a negative. 10 is 71 minus 3, 68. I think negative 68x squared minus just the number 10. And then we have on this side, I got this values here. So I would love to common factor an n out, but I'll still have an n in those brackets. So that's not going to be wonderful. Factoring ain't going to work out too nicely here. Problem is we're going to end up with 4 terms and 2 different sets of variables. 2 different sets of variables, we technically need 2 equations to solve it. We have 1 pair of equations. but only one of them has an n in it. And we're not 100% sure that there is equality between the two of these. The other way I would have tackled this. Okay, there's another way I could tackle this. This may not have been the best path. The reason I'm saying that is because I still have two n's, and I need to isolate a single n. Usually, in order to do that in math, we actually go from this version to a factored form. This is a factored form of it because that brings us to one n, and then we can work with it. We did expansion because that's kind of what you've been working at. But from here, we're getting a bit lost. I'm going to have to just factor again, and I'm not sure I can find this. I'd have to go probably use some kind of factoring software because these are big numbers. This is not going to be easy for me to do my factoring with. I could plug it in, and there may be a factoring software that'll do this. But let's try another algebraic root. Let's see if we can't solve this a second way, the original way that I had said. So we're going to come back down. We're going to say we're not 100% sure here. We'll say we're stopping here because it looks like we're in a difficult path. So we're going to try a different pathway. 13x squared minus 10 is equal to, I'm going to rewrite it. And the reason I want to rewrite it is because I want to show you a quick way of isolating a whole side. This entire side is squared, which means I can get rid of the squared by just applying the opposite operation to both sides. In this case, if I square root, and I just got to make sure I do one side, I do the other. Square root and squared eliminate each other. They disappear. So then I'm just left with what's underneath in those brackets. So in those brackets, we're left with negative 9x plus 72n. That's great. Now my left side's not so wonderful. I got a square root, and there's a variable under there, and it's squared. Not nice, but it's okay because the n isn't actually under there. And remember, my entire goal here is just isolate for n. I got to get n by itself. Doesn't matter about the x's. Okay, so since that is the case, the next thing I'll do is just move this to the other side. So we end up with the square root. Write our square root over again, which is 13x squared minus 10. Now that's all there. Now we move the 9 over, that's going to actually become plus 9x. And then we're left with 72n. N's almost by itself. Let's get n by itself. If I divide this side by 72 and I divide this side by 72, I end up with this. N, which is great. That was the entire goal. What does n have to be equal to? Well, turns out n is equal to an expression. I'm going to write the whole thing out here. Doesn't look like a lovely answer, but answers can be, when you have an expression, what that means is there could be multiple answers to something. 72. This is apparently what n could be equal to. So this is a set of answers. You know, remember we're talking about domain and range? Yeah. You guys talked about that? This is like a domain of answers. There's many answers, whatever x could be. So what we can do to actually visualize this, because algebraically this looks really messy. I look at that and go, what does that mean? There's so many different x's I could try. Let's go. Let's see, do I have Desmos up? I got a Desmos here. Here we go. Let's move it over. Get rid of these two. I'm actually going to put that in. So we're going to put the square root divided by. Nope, that's not what I want. It's got to start with divided by. And then I get a square root. There we go. 13x squared minus 10. So that's all in the bracket. Plus 9x, all divided by 72. Hey. So according to this, there are a bunch of answers. They don't exist here. And they don't exist. Can I get? Oh, it does exist to that point. This exact point's undefined. So it has some kind of asymptote, it looks like, about here. Or we could say x isn't equal to. From there, I mean, we work with the radical. I could start breaking it apart. But have you guys done much work with radicals?
No.
I didn't think so. This is a set of answers. When they're asking you, in this one it says, is there a value of n? There's a bunch. There's a bunch of values of n. This is like a set of a whole bunch of answers. It's just not one nice one. It's a very tricky question to have asked you guys.